check every single direction and see if there's an Xmas there, I guess. Right, so we can let right, so we kind of want a list of directions. We kind of want the -1, -1, -1, 0. So that's going up to the left. That's going, no. Yeah, this is going up and to the left. So if we have X, Y, I guess we'll go clockwise. So then we just want to go up. Then we want to go up and to the right. Then we want to go right. Then we want to go down and to the right. Then we want to go down. Then we want to go down and to the left. And we just want to go left. Okay, so this is our directions, and we want to go for each of these. For each is a thing, I'm pretty sure you can do with lists. If not, we'll just map, because that's what a for each is. We can do the fold as well. I think it'll be easier just, yeah. We can do this as a double fold. But I guess I'm just not convinced that's better. Yeah, so we'll map over these directions, and what we'll map is, or we'll fold over them, I guess. We need to give a direction, sure. I feel like when I'm writing scheme, I spend a lot of time just thinking about what the best way to express what I'm trying to do is. Like, there are so many options, and all of them feel a bit awkward. So what we can, so like one option is we can just map like Xmas question mark over each of the directions. We need to give it the grid. We need to give it the I and the J points as well. And then we can just sum them all up. We can just, you know, fold left plus 0, map Xmas, or map Xmas IJ. Over all of them. And then that becomes like loop, right? And then we need to loop over that. Fine, whatever. We'll stick with this. Whatever, it's fine. Okay, so we need to loop, and we need to go if equals j is it vector length of vector ref I, then Right. Because then we need to do the same thing to know if we're adding 1 to j or keeping j the same. Maybe this is better just as a purely imperative algorithm. Because the thing we can do here, so, all right, so if we've reached the top, then we want I to reset back to 0. Otherwise, we want it to just keep adding, so plus 1i. But then we need to do the same thing for j. So we need the same test, and we need to know if j stays the same. It's actually the other direction. If j increases or if j stays the same. Well, I guess I've already written it, so we'll keep it. And then this whole thing needs to be in a if. This is just so silly. And then we just need to do the same thing here. So we need to know 1, if we've reached the end of j, and we've reached the end of the grid. So then if both of those things are true, return n. Otherwise, do all this. And so then we need our xmas function. For ij, and that'll be a new function which takes in a direction, dir, and then does stuff. So we want to know if all of these things are true. Yeah. Because we need to check the bounds as well. So we'll start with the easy one. We want to know if vector ref I what is the vector ref? Is it you give it the thing first and then the other thing? So vector ref of grid I, j. So the first thing we want to know is this equal to x? Or is it x? It might be x. All right, and then the second thing we want to know, actually that's not true. So the first thing we want to know is if we're in bounds. So we want to know if plus I car de. So xmas has how many letters? 4. So times 4. We want to know if this is greater than 0, I guess. And we define x bound to be times 4 car de, and then we want to add x plus I rather, or I bound. All right, and then we want the j bound we'll just make that CDR. And then I'll make the extremely, nah, fuck it, I don't care. I was gonna make all of those dotted pairs, but that's work. And so we want to know if I bound is greater than 0. We want to know if I bound is less than vector length vector ref grid I. We want to know if j bound is greater than 0, and we want to know if j bound is less than vector length of grid, I think. Ooh. What have I done? Oh, right. Yeah, no, that's reasonable. Okay, so we want to know if it's in bounds, and then we want to know if that first part is equal to that, and then we want to know if the second part, well, okay, let's also define delta I to be CAR and define delta J to be CADR. And then so that can be delta I, that can be delta J. Whoops. Okay, and then we want to know if right? Should be 4. I think it should be 3. And then we want to times, no, and then we want to times, nope, just this one, times by 2, and this one as well, and then this one A, and this one S. Okay. I wasn't expecting that extra one. Ooh, did I not close this? I did not. Okay. Unbound variable end of file, really? Port end of file, okay. Wrong number of arguments, I see. Oh, yeah. Okay. Which one are you complaining about? You're complaining about vector ref somewhere. Vector ref 0, I agree. I meant to give the grid. That is a grid, that is a grid, okay. Vector ref grid. Grid. Okay. Where be this? 45? No. 51? Okay, I can just go to 51.